Welcome back. Today in this explainer, we're going to dive into the construction of a mega project that has literally pushed the absolute limits of human engineering. We're talking about the world's largest, most advanced LNG-powered container ship. To really wrap your head around the sheer scale of this Leviathan, just think about this. It drinks a staggering 100,000 liters of fuel just to start up. Seriously, that's not the fuel to cross the ocean. That is literally just the cost of turning the engine on. When you're trying to move a literal mountain of steel, you need an unbelievable amount of energy right out of the gate.
And this isn't your everyday run-of-the-mill engine room. The engine driving this beast is the exact size of a 6-story building. It's so incredibly massive that maintenance workers can easily just walk around inside of it.
Now, zooming out for a second to the global context. Even today, 90% of all international trade relies on the sea. Whether it's a tiny needle or a massive truck, it's probably been on a ship at some point. To put that into perspective, at any given moment, there are about 15,000 to 20,000 airplanes up in the sky. But out on the oceans, there are a whopping 38,000 cargo ships navigating the seas, completely dwarfing the aviation industry.
We actually have the tech to build even bigger ships, but if we did, they simply wouldn't fit through major canals like the Suez or Panama. So the race right now isn't just about size, it's about building highly fuel-efficient giants. Still, this ship is huge. It's 400 meters long, which is basically 4 football fields laid end to end. It's 61 meters wide, taller than the Qutb Minar, and weighs in at 70,000 tons empty. That's like 7 Eiffel Towers or 11,500 African elephants. If you took its max capacity of 2,312 containers and lined them up, they'd stretch for 150 kilometers.
But what really sets this ship apart is what powers it. It doesn't run on traditional heavy oil or diesel. It's designed to run on LNG, or liquefied natural gas. This is a massive environmental win for the shipping industry. Compared to traditional oil, LNG means 99% less sulfur dioxide, 91% less air pollution, and a 20% drop in carbon dioxide. It is a huge step toward cleaning up our oceans.
The real challenge for the company, CMA CGM, wasn't just building this heavyweight ship. They had to build 9 of them, and on a super strict 2-year timeline. To pull this off, 6,000 workers from all over the world worked day and night at a massive 4-kilometer-long shipyard in Hong Kong. And they didn't build them from the ground up. Instead, they constructed them using giant pre-fitted modular blocks with all the wiring and pipes already installed. The foundation of these ships is made of specialized steel sheets to prevent rust. Just one ship needed 12,660 of these steel sheets. To cut them, workers used a specialized laser beam that reaches a mind-melting 18,000 degrees Celsius. That's literally 3 times hotter than the surface of the sun. It cuts through steel like a hot knife through butter, ultimately slicing 880 kilometers of steel strips.
Once those massive modular blocks were perfectly lifted into place, it kicked off an endless marathon of meticulous welding. Amazingly, a single ship required 1,250 kilometers of welding. If you laid that weld in a straight line, it would stretch all the way from Karachi to Lahore. And every single millimeter had to be strictly checked, because the ocean's unforgiving waves do not tolerate even the slightest weakness.
Okay, let's look at arguably the biggest engineering hurdle of the whole project. Because the ship runs on LNG, it needed a massive fuel tank that basically acts like a giant thermos to keep the gas at a freezing liquid state. This tank is so ridiculously large that you could comfortably fit 6 Olympic-sized swimming pools inside it. Just building this single component took 9 whole months.
Why on earth does it need to be that big? Well, this colossal tank was specifically engineered to hold an incredible 20 million liters of liquefied natural gas. When you're making a continuous, non-stop voyage all the way from Asia to Europe without refueling, you absolutely need that kind of massive capacity. Keeping that LNG freezing cold is absolutely critical. Otherwise, it will warm up, expand into gas, and cause a disaster. So the tank had to be 100% airtight. To guarantee this, workers used a brilliantly simple yet highly effective vacuum leak test. They applied soapy water to the steel joints, placed a glass container over it, and used a compressor to create a vacuum. If there was even a microscopic leak, air would get sucked in and create bubbles in the soap. Pretty genius, right? The final layer of insulation inside this tank is an absolute marvel of modern science. It's a space station-grade wavy steel membrane that is incredibly thin, just 1.2 millimeters. The waves are the secret here. When the freezing cold LNG hits the metal, the steel naturally shrinks. Those little waves allow the metal to safely contract and expand without ever breaking. Moving toward the back of the ship, we find the real driving force. The 85,000 horsepower engine relies on a massive central crankshaft weighing 220 tons. Moving it actually required a remote-controlled platform with 140 wheels. This heavyweight crankshaft transfers its immense power to a 92-ton single-piece propeller that stands as tall as a two-story house.
Connecting an engine and propeller of that size perfectly is no walk in the park. To make sure the propeller shaft is perfectly straight, engineers use a clever blue dye test. They coat the shaft in blue dye, fit it into the propeller, and pull it out. The dye maps exactly where the contact points are uneven, allowing them to adjust it and eliminate any dangerous high RPM vibrations for good.
Before this Leviathan could even touch the water, the hull had to be protected from saltwater friction and rust, which can totally ruin fuel efficiency. So they coated the entire bottom of the ship in 1 million liters of special marine paint. The surface area they covered was massive, roughly double the size of Vatican City. After a year and a half of relentless, around-the-clock work, the very first ship was finally ready. But it wasn't over yet. It had to survive an intense 15-day timeline of high-stakes sea trials. Controlled from a high-tech command bridge using a 360-degree smart eyes system, the crew pushed the engine speeds, tested emergency brakes, and verified navigation systems to their absolute limits out on the open ocean.
During these trials, they also deployed the colossal anchor. And get this, just a single link in the anchor chain weighs 300 kilograms. If you weigh the entire chain together, it equals the weight of 60 African elephants. It's heavy engineering on a scale that's honestly hard to even imagine. Successfully building 9 of these megaships on such a strict timeline just goes to show that human ingenuity and sheer determination can literally move mountains of steel. It's a massive win for low-carbon shipping, but it leaves us with one incredibly exciting question. If we can build eco-friendly steel mountains that conquer the oceans today, what bounds of human engineering will we shatter next? Thanks for joining me for this explainer, and I'll catch you in the next one.